ice skating lessons with Kendra and May. This is Kendra. It is her first ice skating lesson, and she is excited. This is May, and she is the instructor. She will walk us through the physics behind ice skating during the lesson. Rest assured, she is a qualified instructor. Disclaimer: please disregard the skater skills. They are not adequate and do not accurately represent the physics. Please be kind and use your imagination. Thank you.
The first concept is what happens when you push against a wall. When you push against a wall, due to Newton's third law, as you push downward and backward against the ice pushes back on you with equal opposite force, causing you to go backwards. This is also made more easily by the fact that ice has very little friction. Now, what happens when you do a weak versus strong push? Here is an example of a strong push. A strong push uses more force, which then causes you a greater acceleration backwards. And this can be explained by the equation force equals mass times acceleration. The stronger the push, the faster you will move compared to the weaker push. Here's an example of a weaker push. As you can see, she doesn't move back very far or very fast. Here's an example on land versus on ice. As you can see, there is really no movement. The third lesson is what happens if you are accelerating and you are not running into anything or nothing is stopping you. If nothing's stopping you, you will keep moving because of Newton's first law, which states that an object in motion will always remain in motion unless acted upon by an equal and opposite force. Here, she's not able to run into anything, and there is nothing there stopping her. So she continues to move and accelerate. However, in this lesson, she ends up running into something, example, the person and the wall, meaning that she will stop because there is a force that acted upon her, causing her to stop. This also plays into collisions, and collisions to two people with similar masses, so neither person has an extremely large change. The fourth lesson is what happens if you spin with your arms out versus spinning with your arms in. When you spin with your arms out, your body will spin slower. This is due to your angular momentum and the conservation of angular momentum. Your momentum is staying the same. However, you are changing how your mass is spread out. So if your arms are spread out, that means your mass is a lot more spread out throughout your body. Here you can see that her arms are in, meaning that she should be moving a lot faster. However, this is not really the best example. We are not professional figure skaters, but in theory and in actual physics, it works. And if your arms are spread out, you will be spinning slower, and if your arms are in, you will be spinning faster as long as you have the same momentum. Fifth and final lesson is stopping. To stop while skating, you need to create friction because there's really not that much friction happening in ice just regularly. So you need to be able to create that friction between the skate or your blade on the skate and the ice. By turning the blade sideways or digging it into the ice, you increase friction, and this allows you to stop or to slow down. You can see the examples here. Again, not professional figure skaters, so they aren't the best, but you can see how it speeds up, and then as she digs her blade into the ice and turns, it slows down.
Thank you for watching and enduring the lack of skating skills. Now here's an example of our favorite force.